Good morning, boys and girls, and welcome back to day 3 of radical expressions. Today we're going to be adding, subtracting radicals, moving on with all the things we know about them. So let's just jump right in here and let's start off with number 1. When you're adding and subtracting radicals, what you need to keep in mind is you need to have the same radicand. So that's the number on the inside. These all have to be the same. If it's not the same, then you can't put it together. And it also has to be the same kind of radical. So like these are all square roots, so that's good. Because if they're all square roots and they'll have the same number on the inside, the same radicand, we can actually combine them together. If they were different types of radicals, like one's a square root, one's a cube root, you can't put those together. Or if they had different numbers on the inside, then you're not able to combine them. Okay? So basically kind of think of these things like terms. We need to be able to add and subtract like terms, and with the same variable. And so same thing with radicals. They have to look the same. And you're actually going to do it the same exact way. You're going to add and subtract the coefficients in the front. So like in this case here, I would do 5 minus 8, which is negative 3. And then the root 3 part's going to stay the same. Okay? And now in this case, we have this plus root 3 still in the back. If there is no coefficient, remember there's always a 1. And if it makes you feel better, you can always add that 1. And so now I get negative 3 root 3 plus 1 root 3. And that gives us negative 2 root 3. So when you add and subtract, have to be the same kind of radical, and they have to have the same radicand. So as we come to number 2 now then, we do have kind of an issue because these are both square roots, which is good, but they don't have the same number inside. They're not the same radicand. So what I have to do now then is I need to simplify. And maybe when we simplify, we're going to find out that you can actually put these things together. I'm going to highly encourage you, again, when you simplify, instead of using that tree thing to break these down, even though some of these like 12 is a smaller number, practice, practice, practice. Get used to trying to pull out perfect squares. So I'm going to pull out the calculator here in a second, and I'll kind of do my work on there, and then we'll talk about it. All right, here's my work in progress so far. I started with the first one, the square root of 12. Again, when I do this, I always wanted to start dividing by my perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, just to there. Generally, you don't even have to go that far because numbers just get too big. So, and we skip 1. So starting with 12, whatever my number is, I always just, hey, take the number, divide by 4. In this case, 4 went in perfectly. 4 times 3 is 12. So I split it up, square root of 4 times the square root of 3. Or then the square root of 4 is 2 root 3. Okay. And now that one is simplified. I can't, another perfect square won't go into 3, so I know that is done and I'm simplified. Now with the next one, then I started the same process all over again. I did 48 divided by 4. Now 48 divided by 4 worked, but I got 12. And 12 looks big, and from the problem we did right before it, I know I can get another perfect square to go in there. So I want to keep going. I want to find the biggest perfect square that will work. So then I did 48 divided by 9. That didn't go in evenly. 48 divided by 16. Oh, that does go in evenly now. So I could rewrite this and then get them down to that 3. But I could rewrite this as the square root of 16 times the square root of 3. Now if you get stuck, like when you reduce fractions, you can divide by 2 and then divide by 2 and then divide by 2. You can break square roots down the same way and pull out a 4, then pull out a 4, then pull out a 4. But I think it's just better since we're using the calculator. Just keep dividing by perfect squares so you find the biggest one that's going to work. Okay? In this case now, I've simplified both perfect squares. And, well, what do you know? Now that I get down to here, again, we have the same kind of radical. We have a square root, and we have the same radicand of 3 on the inside again. So I can go ahead and put these together. 2 minus 4 is negative 2 root 3. And if you're not doing the tree thing, I mean, that's all the work you're going to have all the time, and it's perfect. Okay, we're letting the calculator do most of the work, and I think that's a good thing to do. All right, trying to really convince us to get away from that square. All right, let me move things around here. Okay, continuing on with our problems now, on to number 3. Again, we're going to treat these radical expressions just like algebraic expressions, because really they are algebraic expressions, just without the variables. So, if I've got stuff in parentheses, okay, again, we are simplifying all this stuff. We're trying to get rid of parentheses. In this case, I would say in order to get rid of the parentheses, again, pay attention to what you're doing. This is a subtraction problem, okay, not a multiplication or addition problem. So in this case, what I'm going to want to do is, my eraser, I'm going to want to distribute the ones in front to get rid of my parentheses. So on the very first one, again, there's nothing there, so there really is this one. So I can put it there if I want to. What if I multiply everything by 1, I'd get what was on the inside. So I get 13 plus root 2. These are not like terms, so you cannot put those together. Right? On the back set now, this is the one I really got to be careful of. That one right there is really a negative one. So as I distribute this negative one, I'm going to have to be careful with my signs. So this becomes minus 7, which we usually get. This is the one we forget sometimes. So negative 1 times negative 3 is plus 3 root 2. All right? And now, again, I want to combine like terms. So there's really no rule in the order we put these things. Although I'm going to tell you when we write square roots, they are generally the last thing in our list. Just that way we don't get confused what's inside or outside the radical. So I think in this case here, I would put the 13 and the minus 7 together as like terms in front. And the plus 2, and the plus root 2. And the plus 3 root 2 in the back. And now we can actually combine our like terms. 13 minus 7 is 6. Root 2, 1 root 2 plus 3 root 2. Same kind of radical, same things on the inside. Add your coefficients for root 2. So I would add just like that. All right. Number 4 now. Moving on. I'll change colors here for us. Number 4. Now, because there's nothing between those things, again, when things are right next to each other, it means we're multiplying. So in this case here, I'm going to distribute. So now we're going to start incorporating some rules from yesterday a little bit. We said when we multiply radicals, you multiply the insides and the outsides. So in this case, it's a 1 root 6 times 2. So I'd multiply the 1 and the 2, gives me a 2. And the root 6 part just travels along. Then I'm going to do 1 root 6 times negative 1 root 3. So 1 times negative 1 is negative 1. And then root 6 times root 3 is root 18. So you multiply the parts that are inside of jail and the parts that are outside of jail. Parts that are inside the radical, parts outside the radical. When you're done, we always then need to go and simplify radicals if we can. So square root of 6 won't work. Doesn't divide by 4. 9's too big. The square root of 18. And again, you could grab your calculator, but the more you do this, you're going to see the same numbers over and over again. And you, in this case, might not even have to. Square root of 18 is, I'll leave that 1 there. The square root of 9 times the square root of 2. Again, the perfect square always goes in front. So now I get 2 root 6. 1 times the square root of 9 is 3, so minus 3 root 2. I have square roots on both of these now, but I have different radicands, different numbers on the inside. So therefore, these are unlike terms, and that is as simplified as I'm going to get right there. That is the answer that we're looking for. Okay, moving up some more. Okay, so far we were just playing around with square roots, but those rules that we were just talking about are the same for all types of radicals. Square roots, cube roots, fourth roots, fifth roots, sixth roots. Okay, the rules we are putting in place are the same rules we'll use with all different kinds of radicals. So same idea here. If I want to add these cube roots together, they both have to be cube roots, which they are, and then the radicands have to be the same. These are different, so we said, hey, what we're going to do to fix that is we're going to try to simplify these. And now in this case, because they're cube roots, instead of dealing with perfect squares, I'm going to try to pull out perfect cubes. So again, I'll do the work on the calculator, and then we can talk about what we did. All right, so again, I simplified my radicals on both these things. Again, I wanted to take the radicand, the number on the inside, and divide by perfect cubes. So when we're talking about perfect cubes, we're talking about 8, 27, 64, 125, 216, 349. Those are the ones that you want to know and have down. So I did 24 divided by 8, went in evenly, so that's perfect. I get the cube root of 8 times the cube root of 3. Again, you want that perfect cube in front. The cube root of 8 is 2, cube root of 3. Okay. On the next one, I did 81 divided by 8. Didn't go in evenly, so that I did 81 divided by 27. And I'm going to tell you about 90, 95% of the time, either 8 or 27 is going to work. You definitely want to know those two. In this case, 27 worked, and again, so I get plus cube root of 27 is 3 cube root of 3. And then again, in this case, because they have the same radical and the same radicand, we can put these together. Add your numbers in front. 2 plus 3 is 5. Cube root of 3. Again, be careful with your index numbers. Make sure they're staying high and tight on the radical, not floating down in front. It's easy for that to start looking like 3 square root instead of a cube root, or maybe like a 2 cubed or a 3 cubed in front. So just be careful with those numbers and the way we write things. You don't want to confuse yourself. All right? 2 more. Okay, for this last one, our next one now, we are squaring this. We said the easiest thing to do when you were squaring something, just double it up. Root 3 minus 4 times root 3 minus 4. Okay? And because there's more than one term, because there's that minus sign inside, we have to double distribute. Square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. Or whenever you multiply a radical by itself, okay, you're always going to get what's on the inside. That's a cool little trick you can use. Square root of 3 times negative 4 is minus 4 root 3. Now negative 4 times the square root of 3 is minus 4 root 3. And then negative 4 times negative 4 is positive 16. I'm going to combine my like terms. 3 and 16 is 19. And then negative 4 root 3 minus 4 root 3. Combine the numbers in front and the radical part stays the same. So we get 19 minus 8 root 3. And now on to our very last one for today, boys and girls. This is a special kind of product. When you have the same number in front, and one's a plus, one's a minus, doesn't matter the order, okay, and the same number in the back, these are called conjugates. And they're really kind of handy. We like to use these a lot, and you'll see what happens. It's a good way to get rid of radicals altogether. All right? So if I multiply the square root of 5 times the square root of 5, since again these are multiplying, we're going to double distribute. Root 5 times root 5 is the square root of 25, or 5. Root 5 times positive 2 gives me 2 root 5. Negative 2 times root 5 is minus 2 root 5. And then negative 2 times 2 is minus 4. You're going to see that this conjugate idea is something that we're going to play around a lot with in math, that it comes up quite frequently. Okay? So it's kind of a good trick to know, good thing to know. But when I put these things together here, the positive 2 root 5 and the negative 2 root 5, 2 minus 2 is 0. So those parts just kill each other off, and they are now gone. Okay? So I'm left with just the 5 minus 4, which is 1. And now the radicals disappear completely. And we kind of like that sometimes. Like sometimes we don't want to have to deal with our radicals in certain situations. And so we can use this idea to help us get rid of radicals. So you'll see it pop up more. Well, that's it, boys and girls. Real quick, easy lesson today. Continue on with the forms and have fun.